begin this workshop. Good afternoon, first of all. Thank you very much, above all, to you for being here so late in the day. I imagine it's been a long day. The presentation we're going to give, well, initially our intention was to give a very practical presentation to show you all the phases of the process from the point when we detect the need of a user, passing through the proposed solutions, evaluation of the solutions, and then the final solution, which would end with the printed product in 3D. But the problem is that we couldn't bring the printers, which are very fast, we have in our center. They're very big objects and they have a lot of data. We couldn't bring them, and then we don't have the time to analyze all the different phases. So what we've done is a mix, a hybrid. I don't know if it'll meet your expectations. We hope so, because we tried to do this best we could. And in this mix, we've included a theoretical side, explaining what we do, how we do it, why we do it. Then we will show you a practical case that we developed specifically to create 3D maps with these printers. In the meantime, you've seen that we have a small printer. It's a kit printer which reproduces a template, which we'll see in the presentation. We'll see the solution. And then if you'd like, you can come up and see how it works, touch it, etc. Okay, so we're going to begin. We work in CDAP, which is the Center of Investigation of ONCE. In this research center, we have a basic purpose, which is to contribute to help people with visual disability to have equal access to the products and services that the rest of the citizens have. And we try to do this in three main ways. First of all, through lines of investigation that help us to develop accessible products. And we study, we're an observatory in a way. We study and evaluate the technologies that arise in the market and try and anticipate events. I'm sorry, this is typical. This happens quite frequently, this noise, the noise of the printer. Look at the products that are available in the market to anticipate with accessible solutions, and we're also reference center in the investigation of visual disability. So we do training and we provide advising services to companies and trainers. Our lines of work, you can imagine, are those which give greater independence to the final user. So anything that happens in leisure, in employment, in education, in the access to electronic information, communication, and all these activities we carry out, we report that directly to the ONCE. We have the CIDA, we have the general resource, maintenance department, the commercial department, and the R&D department. As you can see, all these departments give us a structure that's broad enough and effective enough to be able to achieve our objectives, and both to capture market information, look at the products available in the market, develop products for the market, etc. The resources we've used up until now is primarily a mechanized shop, where we had machinery, alphanumeric type, plastic injection, not for printing plastic. Do we make the molds, and then through some heaters we liquefy the plastic. It's melted, it goes through the mold, and we shape the figures. This is what we had up until now, and it worked fairly well because we came up with good solutions, but there were some drawbacks. For example, we needed a lot of very highly qualified personnel technicians for maintenance for the injections. Uh, and also, as you know, this machinery isn't sufficient for all shapes. I can do different cylinders, different shapes, but I can't excavate, do round drills. So I have a limited production for my pieces, and then it takes quite a bit of time. Keep in mind that from the project we have require plans set up, but it takes time, and the solutions take time to develop. Above all, and most importantly, it's very difficult to correct the design problems because this is you're finishing the prototype. The prototypes cost money, it takes time, and there could be mistakes, but they need to be corrected, and it's not easy. You have to basically start over again, or or develop pieces that help to resolve it, and it's difficult to resolve individuals' problems or individual situations. So then we start to look at the 3D printing. There are many different types of machines. Right now, 3D printing is in fashion. It can do almost everything. We were joking that almost any day they'll start reproducing among themselves, recreate themselves. It's true that it's in fashion, but it's not a new technology. In our center, we've been working with this machine, this thread machine, this object machine, for 10 or 12 years. So it's not new, but it's now that all of a sudden it's being used more and more. Given the possibility of working with this machinery, why? Basically because of its characteristics. On the one hand, there's innovation from the perspective that we can print prototypes in a very short period of time and send them to the final user. And then they can give us their feedback. They like this to be longer, this to be a harder material, and then we can go back and redefine the prototype and print it out in a very short period of time. Also, it can be customized, as I said. We can come up with an ad hoc solution for almost any person, and I think this is something we've been looking for a long time now. We always talk about the participant of the users. The solution should consider the customization, that it's not one size fits all. We've been talking about this for a long time, and now we see that this is now viable. Also, there's the issue of speed. We reduce the development time, the manufacture time. This obviously reduces cost. The cost of our center, for us, that we know there's a budget and we have to meet the budget. But we're also aware that the cheaper the solutions, we can reach more people with more solutions. This is obvious. Also, the optimization of the relationship between the technician and the user is something we've talked about for a long time. We said before, when we come up with a solution for a user, it's the engineer who uses a very complex language, which the user doesn't understand, a technical language, and the engineer doesn't understand the user, etc. Now we can optimize this dialogue. We can show the user a prototype so the user can tell us exactly what he wants based on the prototype. So the sequential process that we carry out is very simple and effective. Obviously, it starts with detecting the need, determining the need. Our professionals, whether they're the rehabilitation technician or the educational people, detect a need, and they tell us. This could be, for instance, ceramic stove. You know that they'll have touch controls with sensors now, these ceramic stoves, but they can't be detected by people with visual impairments. You'll see this solution that we have resolves this problem. So we look at what the possible solutions are, the cheapest and most effective solution, and we decide the simple solution is to develop a template which solves the problem, perception problems for those commands that are necessary to control the stove. In other words, to activate a burner, to increase or decrease the temperature. That's basically it. And of course, to turn it off and on. That's basically what we need. There could be other commands as well. It can have other features such as timers, but that's accessory. The main thing is what I just said. So the solution that we came up with is to build a template in plastic like the one you see here to solve this sensorial problem. And what we do is attach it to the edge of the stove. It doesn't move, and the user, when we give it to him or her to test, so this was the first solution we came up with, and the user was very happy, and it was very quick. The results were so positive in this 3D printing that we're applying it to many areas: education, employment, rehabilitation, the daily data activity. In education, primarily what we're doing is look for solutions not just to adapt objects, but also to adapt concepts. This may sound unusual, but when we see an example, you'll understand better what I'm trying to say. The ONCE in education has a team called FEDO, which is in charge of looking for technological solutions in the classroom. This group, when it detects a need or thinks that it's important to innovate in the classroom, they let us know, and we have a multidisciplinary conversation between the maintenance technicians, the rehabilitation technicians, the educators, etc., ergonomers. We come up with proposals or solutions, and in the end, we decide on a prototype, which is then evaluated. I'll give you an example. Maybe you know, and it's very difficult to explain to a blind person in a graph how we move the values, although we're just talking about two axes, x and y, when we change the value of the variables. In other words, with that, if they can't see, this is very difficult to explain. It's hard to imagine. How does the curve change? Why does it change? Why is it steeper or smaller? This requires an haptic perception so that the student can learn the concept. That's why I mentioned before adapting concept. Well, we can manufacture mathematical functions and graphs and trigonomics. In addition, if it's difficult to understand mathematical concepts, it's not less difficult to explain concepts or artistic concepts and ideas. How did we learn or study history of art? Well, I studied it a long time ago. I learned by seeing the paintings in the books and explaining columns. How do you explain this? Explain architectural columns. Well, I understood it because I saw it, and in the best of cases, we went to visit a cathedral on field trips, etc., and teachers explained it to us. Well, now the students learn with videos, and the knowledge is easy to transmit this knowledge. Well, our blind students, the only way they have of learning through their senses is by touch. The way they acquire knowledge is through haptic perception. Haptic perception is active touch. I learn characteristics of what I'm touching. This is called active perception, haptic perception. So not everything is art, and not all the artistic objects are available to be touched by people that can see or by blind people. So we saw there's an important gap there, and that we could come up with two-dimensional templates or molds, and through a thermoconformal technique, we could come up with figures that the students could touch, but it was two-dimensional. So we realized that we weren't explaining the concepts. It wasn't sufficient to explain an artistic concept. Through 3D printing, we realized that we can add more value so that to help transmit these concepts, we started with 3D figures like the one that you can see here on the slide. And we've gotten such good results that our Tiflotic study has allowed us to develop models and objects to show them and to in the museum. And this has been very positive. In the school, we not only adapt objects, but also concept, which is the most difficult. But with regard to objects, to adapt the way that our students learn about objects on the iPad. If you're not seeing it, even though we know that the Apple iPads and the smartphones have accessibility applications, are blind users, when they touch these devices, they can touch places that aren't important, or we don't want them to touch it because perhaps the applications that we want them to run are different. So we establish a framework, a border that's outside the tablet, and we can insert the templates. This one has several holes to allow the student to go to that area that we want him to go to. So they'll only touch this area. This is very simple, but it's very practical, and it solves quite a few problems. In the day-to-day activity,
as we advance in technology, we make things smaller, although these can create a lot of problems in handling this type of devices. We have done some adaptations of computer mouses that can be used on motorized wheelchairs, and we do them very fast. And the user goes home very happy. The adaptations that we do for leisure activities is another thing that we take care of at ONC. People at ONCE try to emphasize these type of activities because we know that by playing in the initial stages, kids learn more than they would do in a classroom, not only working with their psychometricity, not only working with concepts, but they have to socialize, and the best way of doing so is by playing. I want to emphasize this because sometimes we tend to solve problems, complicated problems, but we never take into consideration things that have to do with gaming. It seems like playing games is not important to us anymore, but in my opinion, this is essential. We have to work on these. We have done several adaptations from the simplest ones, like tic-tac-toe, towards geometrical figures with strange shapes so that the person can touch it. This one is part of a game that we did with UNED, UNED, to build a scale of to evaluate the optical perception of the individuals. Same thing with chess. We've built a clock like the ones that are used in chess. And as conclusions, the reduction and even the elimination of the problems what they had with the previous technology that we still use. We still have a workshop with good machinery, but we are being more efficacious with the new 3D technology compared to what we were before. We have optimized the implementation time. We've also been able to improve the communication between technicians and users. And not to be very repetitive, what we're going to do is to go to a case study. This is an application that we have done together with the University of Jaén, JAEN. This is an application to build and to model plans so that they can be afterwards printed in 3D. We are using an open source code program, Quantum GIS. We have customized it. We've changed some of the standard tools by others that we needed. And at the end, we get plans that can be used as a template to afterwards copy them in this old process that we used to have. And or we do these models, these 3D printed maps. We started with this Quantum GIS, a program reader for blind users, and this 3D printer and blind maps. This is the application that is being developed with collaboration with the University of Jaén, JAEN. This is the Quantum GIS that you see on the map. These are the tools that we've introduced to customize it so that it can be used at home or at schools from La ONCE, so that without then becoming experts on the program. We have eliminated most of the tools available on the program, but we've left the ones that are important to us. I thought that I could explain the process, but I'm going to go as I do. It takes a little bit to load the program because we have to upload a lot of information on the program and many maps that are very heavy to upload. But with the information in it, we can build a map in a very fast way. Of course, we get access to the databases of the geographical institution in Spain, and the maps that we download from there have to go through a process that can help us to work with them in a digital way. The maps that I have here have already gone through that process, otherwise it will be too long. So we start with some templates so that I can choose the best one for the map that I want to develop. I want to do maybe a physical map, a topographic map, a relief map, or build my own template. Let's get this city map. We open it and we have to enter different layers. This is an overlapping of layers. In each one of the layers, we have a different height, a different relief, so that we can differentiate the different layers. And I can configure the layers the way that I want. I do not need to respect reality if I don't want to do so. We're going to be looking first for buildings. These are buildings with the format appropriate for the program. Now I can add the industrial layer. If I don't want to add the industrial layer, I just cancel and I go to another layer. But in this case, I'm going to add the industrial layer. These layers are overlapping, then I add the green areas that are interesting for me. So I look for the green areas areas, and I include it as a new layer. And when I finish with all of the layers, I know that you cannot see it really good on the screen, but these are digital data. And now that I have my map, I'm going to build my 3D model that will be afterwards sent to the 3D printer. I can add maybe labels with the names. For example, the name of the building. It says cathedral, for example, or whatever. With label of the places so that we can print also the name. And then I click on building the model. I go into a new menu in which I enter all of the parameters. I can choose all of the layers like the ones that are here, or maybe I can eliminate any of the layers. In this case, we're going to add all of them, and then I define the area. I can define what I have there outside, or the extension, the full screen, or only, I don't know, the industrial layer. Let's say that we are going to do the full screen, and then I'm going to define the model. In this case, I have to enter the printer that it is installed so that afterwards the map can be printed. Depending on the printer, the parameters are different, and also the size of the map. And I can choose a very high resolution, mid resolution, or a low resolution. If I choose a very high resolution, it will enter a lot of detailed information, but maybe that's not so interesting for me. We'll have to test it. And with regards to the size, I might have a width of 100 centimeters, and they will solve the rest of the parameters. We can respect the reality as it is on the map, or maybe if we want to highlight certain things more, we can add an exaggerated factor 3.5 on certain areas, so that we'll have something that it is very big to touch. Or maybe we can adjust it proportional to the maximum height. But we will adjust the parameters based to the maximum height that we have. If there is a high hill, it will be based on that height. And we can use this to build a mold afterwards. We can habilitate making holes. I don't know if you see those red marks, but these are holes that are going to be made during the printing. This machine has a an air vacuum functionality that will be able to absorb part of the areas, and it will make the copy in a more optimized way, and with this vacuum pump. And I decide how many holes do I want, if I want a lot of them or not so many, and because I will be drilling the map, I can get only the city center, the graphic scale. I can enter the text of the type of map that I'm printing. And with all of these, I'm going to click in export, and this will be exported to a modeling file. We'll, we'll give it a name. We'll say in this case, test for the Congress. And with after exporting this, it will process all of the data, and it will put it in a format that the 3D printer will understand. And the map that I will obtain, well, I will get the file on a pen drive, or in, I don't know, on a SD card or whatever. And I'm going to take it to the printer, and I will start with the printing. Now I found a file, and with this program Cura, I can see the final result, because this allows me to visualize the 3D result, and I could even introduce some minimum modifications, for example, some details in the labeling that I've done or in the written test. But you see there the relief, the buildings, and the 3 layers that I enter have overlap from the basis that I chose, that was 3 millimeters. Do you see this in great detail? Let me see if I can do it so that you can see it better. You see these spots. Here it says building industries and green areas. Here in the upper right corner, there is a rectangle, and it says the size of the map. I think it says A34, 834 meters. That's the scale that I decided based on the parameters that I enter. So this whole bar corresponds to 834 meters. And you can see in the upper left corner it says N, highlighting where the north is located. I can put the labels wherever it is that I want to put them. Not to hide information, because in this case this label is too big and is hiding a lot of the information within the map, so I can remove it or I can change its position. And that was just about it. So let's show you a video, a very small video that has to do with the printing of this piece, but in a real machine, the real solution that we had. We started doing a modeling process at the computer with a CAD program. We decided at the computer. We always ask for the measures to the manufacturer so that we don't make mistakes. We're modeling this on CAD, as my colleague Guillermo has made, and later on fast forward the video because we don't want to.
Sí, porque acaba de puesto entero. Yo he puesto el nombre y la referencia, no sé cómo ver, pero bueno, sí, he puesto unos radios, ahí se puede hacer.
Very good results with this technology. It has provided important solutions for all of us, and if you wish to formulate a question or make a comment, or if you want to come here to see the machine or the piece, we will be more than happy to help you. Thank you very much for your kind attention. And here you can see all the pieces that we've brought with us. Thank you very much.